My name is Anil Sawhney. I work in the RICS sustainability team. I'm also a fellow of the RICS. I want to begin this webinar by thanking iMason's Climate Accord. We have begun our 3-year collaboration agreement between iMason's Climate Accord and RICS now become part of the movers community within ICA. So this is the first in a series of activities we'll be doing jointly. I also want to thank Santiago from iMasons and Miranda from iMasons Climate Accord for helping us make this happen. As you may know, RICS has the world leading standard for conducting whole life carbon assessments. We also have integrated our WLCA standard with a global cost management standard, namely ICMS. So with the help of our standard, our member firms can report life cycle costs alongside whole life emissions. In today's webinar, we will be discussing this very important topic, bringing whole life cycle approach to decarbonizing data centers. Our economics team works closely on this asset class, and they recently published a couple of articles that are available on our website. And as per the data and other publications, I think last week IEA produced a report on AI and energy focusing on data centers. As we all know, the power consumption is going to grow as the growth in the data centers takes place globally. There's a rising concern that by the use of fossil fuels, this could lead to a large growth in CO2 emissions also. So with increasing investments in this sector, there's a very important opportunity for all of us to drive sustainable solutions and form the blueprint of decarbonized data centers and digital infrastructure for the future. To me personally, this is such an important topic because our members, so for example, cost planners, quantity surveyors, today use several AI tools. So that drives the demand of AI. They work on data center projects. So it's a very interesting intertwining between use of AI and the growth in data centers. And therefore, keeping an eye on these competing demands and making the digital infrastructure sustainable is crucial. So in partnership with iMason's Climate Accord, today we are going to explore strategies for reducing data centers' carbon impacts. I think we have a brilliant global panel with leading experts practicing in this space. They all bring a very different worldviews into this. So let me now begin by introducing our panel members. First is Gemma Grant. She is the senior mechanical engineer from Arup, based out of the UK. Gemma, if you could come and say hi to our participants.
Hello, everyone. So as Anil said, I'm Gemma. I am a senior mechanical engineer working at Arup out of one of our UK offices. So as a kind of a global engineering consultancy, we do a lot of design work for data center providers, so new build and refurbished buildings as well. And I've got particular interest in embodied carbon assessment for data centers.
Thanks, Gemma. Next is Amy Marks, Senior Vice President for Compass Data Centers. I can take the liberty of calling her a good friend. We worked previously together. Welcome, Amy.
Hi, thank you so much for having me. Again, my name is Amy Marks. I'm here at Compass Data Centers, and we are a single-tenant hyperscale developer and owner operator. And under innovation in our group, we focus on things like new ways of making, industrialized construction or prefabrication, all of ESG, as well as human-centric, worker-centric initiatives like safety and workforce development, as well as any technologies that support the business and make us all more productive. So thank you for having me.
Thanks, Amy. Next is Pete DiSanto, Executive Vice President, Data Centers for Enchanted Rock. Welcome, Pete.
Thank you. Thank you, everybody. Thanks, Anil. Yes, Executive Vice President at Enchanted Rock. We are a natural gas microgrid provider behind the meter, in front of the meter, and providing resiliency and availability, as well as grid flexibility and speed to market in grid connected microgrids that are natural gas. Thank you.
Thanks, Pete. Just to share, Pete is currently in France. Amy is in the great state of Texas. I'm calling in from the east coast of the US, and Gemma is in Leeds in the UK. So we also have over 450 participants currently representing about 55 countries on this webinar. This webinar, we would like to make it as engaging as possible. So please do submit your questions to our panel as we go along. It will bring the conversation live. These questions will come to us and we can utilize those and weave into our discussions and make them make the discussion even more interesting for you. If we can't get to all those questions, we do provide a written response in terms of a blog or an article. So there is a question box that you can see on your screen. Please use that to share your questions with us. So with that, I'm going to move on to our first question, which is actually setting the stage, getting all your views, and we could use that as an opening statement. I can already see some exciting discussions, big picture to a very specialized discussion on embodied carbon. So the first question, and we'll have Pete start, how widely are decarbonization solutions being used when designing, developing, and operating data centers currently? So Pete, Amy, and then Gemma.
Sure. I would start off by saying, like, this, there's a speed to interconnection as this massive power constraint that's holding up or slowing down some of the data center AI data centers in particular. And I would say that there's no question that the industry is stepping up on sustainability. But when you think about that bridge period and that bring your own power, because an interconnection to the utility, which is the cheapest and greenest electricity from a sustainability point of view, it could be 3 years, 4 years, 7 years in some instances before you get the utility interconnection or before it's ready. And a lot of times the emissions during that bridge period may get overlooked, and it's a huge contributor to CO and everything else. So, and the industry is still somewhat defaulting to diesel in this bridge period in some instances, which is fast. But like I mentioned, it's one of the dirtiest decisions on the project that can be made for that bridge period, and it's tough to manage diesel coming in and out as well as some of the other prime movers that are out there. So if you're thinking more about a modular hybrid system that is maybe natural gas, that's battery storage, that has some other renewables in there with the different operational characteristics, you can still move fast while thinking about long-term emissions from a sustainability point of view. And I'm seeing more as I travel and I speak to utilities that there's a shift globally of how grid flexibility is being recognized as a lever for speed. And if you can secure it, and I'll talk about this more in the other questions and panel discussion, but partial interconnection and a flexible interconnection is actually, it's not speed to power, it's really more the speed to interconnection, so that even if at 5 or 10 megawatts ahead of schedule, you can reduce that bridge period or that time when you're bringing in temporary diesels and move towards a lower carbon source of power, which is the grid itself.
Well, I'll go next. How about that, Anil? I think, decarbonization solutions being used today, adoption varies really globally. Some markets are obviously policy driven and some are more owner led. I think the hyperscalers are driving a significant, level of adoption of sustainability requirements at this point, with, the key contributors to the environmental impact being energy usage and embodied carbon and materials, cooling systems, of course, water, as we move to encompass hybrid air and liquid cooling. But the pace of adoption is definitely increasing, albeit somewhat fragmented. And I think that the leaders in the industry, like Compass, are self-imposing, standards and some others are lagging behind. But for us, to be fair, we're not checking a box. It's really more of a reflection of how we think, act, and do our business. And sustainability is a great outcome of doing the right thing from a business sense for us. And I believe that, we believe that embedding ESG into all phases of our design, delivery, and and operations through the fact that our culture drives those decisions allows us to really operate with transparency and integrity without having to make sweeping statements about what we could or would or should do. It's really just more about holding ourselves accountable to our culture of always doing the right thing and being a great neighbor and being a good member of society, if you will. But I think it's more, we're seeing increased adoption of decarbonization solutions, mostly driven by requirements of our tenants.
Thanks, Amy. Over to you, Gemma.
Yeah, from a design perspective, which is, I guess, where I'm coming from, we see a lot of the larger kind of hyperscalers and the co-location providers are already focusing on energy consumption, and lots of data center providers had done for years now, and operational has been kind of the forefront of what everyone's been thinking of doing, driving down PUE values and saving energy. But as kind of the grid is decarbonising and there's renewable tariffs out there, the embodied carbon is becoming a key focus, or it should be becoming a key focus, because that is still going to be there. So when we're kind of going through the design process with data center providers, we're thinking about kind of applying more circular thinking. So do we need it in the first place? Probably yes. Can we reuse things? Can we refurbish elements instead of installing new? So it's really about kind of adding that extra thinking to the decarbonisation, and not just kind of improving energy efficiency and PUE figures. And I think there's probably a difference as well between the new build. So a new build data center, we can easily put in energy efficiency measures, and we can make sure it's really kind of top notch from day one, and it's a low carbon design. But there's so many existing data centers out there that are probably not running as efficiently as they could do. So I think there's a lot of opportunity for existing data centers kind of improve efficiency. But yeah, I think the focus needs to be kind of being brought onto what the embodied carbon of these buildings are as well now.
Thank you. I think I want to really take those 2 points that you raised, and before moving on to the next question, try and better understand the situation with existing data centers. When we talk about buildings, especially in mature markets, we do pay attention to existing buildings. So what's the situation with existing data centers? Because the news cycle, you always would come across new data, billions of dollars worth of new data centers being produced or constructed. What's the situation with the existing stock, one? And is the message about whole life approach reached the data center market? Especially, Gemma, you've raised a very important point. As grid decarbonizes, the portion of the embodied carbon that's trapped into a data center is going to increase. So just maybe, Pete, your views on existing data centers, and Amy, how you see the importance of embodied carbon rising.
Sure. On existing data centers, I think from a power generation side and what they have on site, there's some DC Flex and some other programs on how to better use the assets that are already there in support of the grid, and those type of programs. But it's with it being diesel, there's not many hours from and it's a dirtier fuel. And I know you can use hydrogenated vegetable oil and some other green diesels, but they're not necessarily readily available at the size and scope that would be needed. But again, just partnering with the utility and having some of the flexibility and a demand response capability, and it definitely stays on track from a green point of view and sustainability.
I mean, when you talk about HVO, we were one of the first people using HVO, first groups using HVO, and we continue to use HVO at our data centers when, exactly as you said, whenever that fuel is available, that is the fuel of choice for Compass. But I think, you have to think, you asked if we're thinking about it from a life cycle approach, and I think again, we're thinking about sustainability as an outcome of, lowest total cost of ownership and built to last. So the fact that we're doing, at this point, I think 74% of our building is factory built, from components to equipment to assemblies, and we're increasing that amount so that we can make each of those components fungible for our customers' needs, and so we can keep using our standard designs regardless of what technology comes out, and it makes us very flexible to be able to adapt very quickly. But I think we are definitely thinking about the entirety of the life cycle when we work with creating new products with our partners. You've probably seen the DH400 with Schneider that we've come up with, and Vertiv, our products with them, the cool flex phase for multi-trade hacks, if you will. So I think we're always thinking about how do we look at these assemblies or these pieces of equipment, or even with Siemens and our skids that are coming up for the 100-year campus. We're not talking about 50-year life cycle anymore for buildings. We're talking about the 100-year campus. And I think when you change your mindset to the 100-year campus, as Compass has done, you can't stop yourself from thinking about what's the most sustainable way to build, because if we can buy something up front for more expensive and not have to replace it for 100 years, that's inherently more sustainable than creating a cheaper option that we buy 5 times over that time period. And I think that's where I believe we are truly contributing to the industry by leading the way when it comes to things like the new GRESB assessment that we're working on with iMasons, or participating in the climate accord with iMasons. We want to make sure that people are thinking about these for 100-year decisions. And I think that is a big change, Anil, to somebody who's just going to flip a data center, buy a data center, sell a data center. It's really the result of good business that sustainability and things like industrialized construction are coming to, and decarbonization to the forefront, if you will.
Fantastic. Believe it or not, we already have audience questions. The first one is from Anna, and it's for Amy. Can you give some examples of sustainability requirements Compass is getting from its tenants?
Well, obviously, I think right now, with the change in liquid cooling, that hyperscalers are, excuse me, a little bit more focused on water usage, and we've typically had a WUE of 0 in the past because we were doing air cooled, but we do have a closed loop system, and we are making sure that we're able to accommodate the asks of any of our customers within reason of what water usage is there. And that is a big change, I think, in what's happening in the industry as people move to more hybrid liquid cooling systems. So that's one area I think we're seeing in a change. I think we are seeing a lot of our customers love the fact that we have early adopters of HVO fuel. We're seeing a lot more on questions around things like working with our partnerships and what we're doing, with them, so that our partners that we use downstream are doing less packaging when they ship things to us. They're using less copper, just in general, that we're doing more with less. And that really shows in some of the questions that they're asking us when we're talking to customers. But I think there's just a renewed focus, or a continued focus, on making the right choices and decisions when you're thinking about materials or partners, or cooling choices and energy usage. So I wouldn't say that it's inherently different than maybe years prior, but for the fact that most companies are moving towards different cooling systems. And these are things that we've been tracking all along. So for us, it's not really a big difference when people ask us for information, because we're very data driven anyway for the 100-year building, so 100-year campus.
Thanks, Amy. The second question is from Luca. Then Gemma, maybe you can start, and then Pete, you can pitch in. What do you believe is the biggest obstacle to decarbonization solutions being more widely implemented in designing, developing, and operating data centers?
I think there's kind of an issue around sharing data and understanding what is going on at the minute. So benchmarking is a big, it's quite tricky, I think, because sharing of data is historically not always done between data centers. So I think understanding where we stand now is important, and being able to benchmark, what is our carbon at the minute, what is our embodied carbon at the minute, because it's not widely understood, and the data is quite hard to get hold of. So I think understanding better where we are now.
Pete?
I would add to it from the power side of a reliance on diesel for resiliency, right? There's other prime movers out there. There's other fuels that are less carbon intense. And when you think about, and do you even need a diesel backup at all with some of the other types of microgrids and other things that are grid firming that are out there? That I think that's one of the mind shifts that's starting to happen. More conversations with the utilities and more other type of demand response or flexible interconnections again that are starting to propagate and have more pickup in some areas that are tough to get power.
Maybe I'll answer that too, Anil, in a different,
Sure.
totally different way. I think that one of the biggest constraints is that most people, when they're describing a new idea or they want to do something different, sometimes fail to talk about the business reason for doing that and the return on investment for doing something that is good for the environment. And we're not measuring things for measurement's sake, that there are things like, cheaper cost of money with green loans and green funding, and there are things that create energy efficiency, even though we don't often focus on that part of it, but you're focusing on the idea, not the outcome. So I would say, most of the time that people are struggling, it's because they don't actually tie it to the business outcomes that are important to our business. And when you can do that, and it makes sense from a cultural perspective and a business perspective, the choice is very clear. And it usually ends in being the most efficient, most sustainable choice because it's a good business decision. It's a sound business decision. It's going to attract lessees. It's going to drive better return on investment. It's going to drive down the cost of our materials and things like that. I just think that is the biggest holdback now, that people tend to focus on only the environmental impact and not the great business case that usually can be made.
Excellent response. Just to add to that, and let's move on to our next question as well. That's why RICS has, in the Whole Life Carbon Assessment Professional Standard Second Edition, integrated that with ICMS so that alongside your emissions for each option that you're studying, you can also report life cycle costing. So because I think cost or business drivers are crucial to consider in the real world. Also, Gemma, to your point, RICS has, in collaboration with other sister organizations, developed currently in the UK built environment carbon database. So if more and more, and it's a neutral, non-proprietary, open, free to use benchmarking database, if more and more providers can report their data about assessments, then the benchmarks can be built over time, and that could solve one of the data issues that you pointed out. So moving to our next question, how best can the decarbonization of data centers be achieved at the scale and speed required? So let's start with Gemma, then Amy, and Pete, you can pitch in.
So I think we've already touched on this, is about existing buildings are quite a big opportunity for saving energy, and a lot of those would have quick wins, say, in them. So there's a lot of kind of efficiency measures that could be generally applied in new buildings that aren't in older ones. So thinking about, chill water temperatures and air distribution, kind of easy quick wins that could be applied in existing buildings. But in terms of newer designs, we do quite a lot of work with data center providers who use reference designs across their kind of portfolio of buildings. And it's quite important for us to be involved really early stage and have an influence over those reference designs, because those then get applied in multiple different locations. And if we can have a kind of early input on helping out with energy efficiency, then that can be applied across many buildings in the future. So that's a really good way of applying savings across lots of buildings. And I think one of the other things that we actively try and do is push supply chains as well. So we do a lot of specifying of equipment, and we try and add into our specifications that suppliers need to provide embodied carbon data in the form of an EPD or TM65 data. But we kind of actively talk to suppliers when we're specifying and say, well, can you provide us data? Or if you can't, when will you be able to? Because people are going to start needing this, and we need it to feed into our designs. So it's pushing that side of the supply chain as well. And it's just generally kind of promoting circular principles to the whole design team, really, and kind of educating and make sure people are aware and kind of because it's almost a change in thinking about how we've done before. Is, you know, we've not really applied this kind of thinking on designs before, so it's important to kind of engage and encourage the whole of the design supply chain to be thinking about it.
Thanks,
I
Gemma.
definitely,
Amy,
apologies, Anil.
go ahead. No,
Oh, no, I would definitely agree with, a lot of that. I think we have to reframe the question. Everyone's looking for speed. That you say the word speed in the data center industry, and you're pairing an industry that is doing everything they can to do things faster and better, right? More efficiently. And we've paired ourselves with an industry of construction, which has typically been an industry that is just trying not to lose. And that makes it somewhat challenging putting those two mindsets together and hoping you're going to get a great result and sort of, I always say hope is not a strategy, as we say, right? So the thing is, when you're looking at the question, there are things like, GBI, and they were primarily doing building certifications. And I'm not sure if you heard, but we've just co-developed the campus approach certification with them so that we can think bigger, more standard for more of the campus, the bigger approaches. And in order to do that, yes, it's great, Gemma, as an example, with standard reference designs, as we have our prototype design, we call it. But you can only go so far with a standard reference design when your supply chain is going to be completely different everywhere you go. And the construction industry has tended to lean towards that transactional bidding mentality, where at Compass, we 100% lead towards a closely coupled partner mentality, because no one is going to do anything for you if you're only going to use them once. No one is going to innovate with you or give you the best information or evolve their product assembly or their product if they only are going to see you occasionally or if ever. And I think that that's the thing that's really been missing from our industry. And we've actually just done some research around industrialized construction and closely coupled partnerships, that you will get only so many ESG benefits when you have reference designs and you go out to the market, but it will exponentially increase when you are at scale with partners that feel comfortable that they will continue to have scale with you. And we, succeed and fail together, but ultimately the benefits are far greater when you take that standard reference design and you have a closely coupled partnership in your supply chain. Because without that, you truly are hope as a strategy is what you're looking at.
thanks, Amy. Pete, if you could connect that to the decarbonization to the supporting energy infrastructure and how that plays a role.
For sure, and what Amy and Gemma said is spot on. But I mean, when you think again with speed, and then the scaling of that speed with the hockey stick approach to how much AI is taken off, as well as cloud compute and everything else, it's really to treat that power infrastructure more as an enabler versus the mindset of it's a constraint right now. And I got to think about it from that aspect. So when you can't get full grid service up front for the interconnection that you're looking for, the full design. I mean, right now, if I'm building a 200 megawatt campus, a lot of times the interconnection request is for the full amount and for firm service from the utility. And if you can design a more flexible bridge power system that's low carbon from day one, and not just reliable, but future ready, that's hybrids, hybrid microgrids with natural gas, batteries, smart controls, and those microgrids can be relocated or repurposed or grid parallel as the site matures. But the real unlock comes from that faster interconnection process, right? So if you collaborate earlier in the process, during the design and the siting, that you can probably negotiate with the utility is somewhat of a staged interconnect or temporary grid access that really just shortens that brings power to the site in months potentially, or even shorter years, because some of it's 4 or 5 years before utility interconnect at the full scope or the full firm power. And once you dramatically shorten that period by a flexible interconnect, as the load doesn't all show up on day one, right? So if you can shorten that emissions heavy bridge period when you're bringing in temporary power and get to the clean utility electrons faster, that's, I think, really helps meet scale and sustainability at intersecting lines.
Thank you. I think that leads us to our next discussion. If today, if you talk about the use of AI, it is Okay, let's try one more time. Sorry about that. So I think the question is really, the next one is to deal with the use of AI. I think pretty much in my network, folks are eagerly using AI to not only drive their own personal productivity, but many of our construction colleagues now use AI-enabled tools, if not AI-first tools. So the use of AI is rapidly accelerating, and that obviously accelerates the demand for data centers, as we are seeing in the news cycle. So how can AI and other digital tools help to rapidly reduce the environmental impacts of data centers? And that's sort of the interconnectedness between the digital infrastructure and the folks like our members and member firms who do measurements, who do benchmarking, as Gemma was saying, brings about that interconnection between decarbonization and AI and data centers. So if you could all please share your views on what's happening in terms of AI-enabled digital tools and decarbonization in the data center space. So we'll start with you, Amy, then Pete, and then Gemma.
Sure. I mean, you know, Anil, I spent 4 years at Autodesk prior to coming back into Compass in the data center world. I think, look, at the end of the day, there's a tremendous amount of tools that are fantastic out there to understand decarbonization, from anything from, you know, looking at component parts to understanding the whole life cycle carbon analysis of our buildings, to using AI in things that are just, you know, everyday processes like in our project management or pre-construction or site adaptation, all of those things. But I would say the thing that we try to focus on is people first, then process. Do we have a process in place to understand what this could be? And could we get a tool that would actually help us understand that workflow quicker, better? Can we train a model? So I think I would always just remind people that there's a business outcome for doing these things. Like, people with AI tend to go like really deep, really fast. And I'm like, wait, why are we trying to do this? Like, what is the reason that we're trying to do this? And by the way, I use AI 50 times a day in my own life. I think it's the most fantastic thing in the world. But I do think people first, process, and tools, and understanding the outcomes that you're looking for is super important than just throwing a bunch of AI at stuff and just doing AI for AI's sake, if that makes sense. And I think, you know, it's allowing us, though, of course, to connect the data using great digital tools that hopefully cut down on some of the siloed activities that have been happening over many, many years. But again, business outcomes that you're looking for, and focus on people first.
Yeah, I would add to that from a power and resiliency point of view that there's a lot more AI analytics for how carbon intense is the power of the electrons that I'm using, that I'm taking from the grid. And when you marry that type of AI with dispatchable on-site resources, because you brought your own power during your build, of really, you know, what's going on with the electricity I'm getting from the pole, and can I arbitrage that between what I know my on-site generation can do from a carbon intensity, and do I shift between the two and really get the best outcome from a carbon intensity and the fuel source, and exercising the equipment so that you then also can use some predictive analytics of what's, you know, the more your generation runs, the better you know what the health status is, and taking all those data points in from your on-site generation, so that when you really need it, when there's a grid emergency or a loss of utility power, as we've seen that can be widespread, whether it's Winter Storm Uri that some of us experienced in the United States, or the Iberian Peninsula with that, you know, cascading event that just happened just a couple of days ago, a week ago. Using that AI from predictive analytics, but also the carbon intensity of the electricity you're using, I would say is very helpful.
I think from a kind of a buildings perspective, there's AI tools out there that can help in optimizing systems, and optimizing the support systems in a data center can save a lot of energy. So normally a chill wall system would run off kind of off a control system which is quite reactive to changing conditions outside, whereas AI systems can do that predictively. rather than reactively. So like Google's DeepMind kind of technologies, they've demonstrated that they can save a lot of energy by incorporating these systems within the building, and they require kind of, you know, sufficient monitoring to be in place and given, you know, control of the systems, but there's real opportunities for saving energy there. There was an IEA report produced very recently, and I don't have the numbers written down, but there was talks in there about how if AI was applied broadly across all buildings, not just data centers, that there could be a significant amount of savings because of the controls that they can put in place. And it's kind of interesting as well, that balance of what can they save versus what it consumes in the first place. I think that'd be a really interesting graphic to see. But there's definitely opportunities to implement them in building control and save a lot of energy there.
So just to expand on our discussion, and Amy, you brought a very interesting idea, which is probably a very real thing, not just focus on technology, it's about people and process also. Do you see any skills gaps or competency issues in the supply chain or the project delivery networks for data centers? We can start with Amy and see RICS as a global professional body is very keen on understanding the future skills requirements. If you could briefly touch on that, Amy, Gemma,
Sure.
and then Pete.
We are, I mean, listen, you and I both, I think a few years ago, did a report on the workforce development issues and trends of the fact that we need, you know, more people, and that's obvious. Again, you know, we're looking at speed in the data center space, and the construction industry and AE firms have everyone retiring at record pace, right? So that domain expertise is leaving. But on the data center side as well, you know, we have to combat that because, first of all, for every data center that goes into a neighborhood, we're creating for every, you know, data center job, there are 6 other jobs created outside of that data center job for that community, not including the construction jobs. So we've got to train up and skill up not just our data center people, our construction people, and then there's going to be some jobs created from this. And I believe, you know, it's one of the reasons we're investing in things like Texas State Technical College. We just launched the MEPI course that you can take 6 weeks full-time or 12 weeks part-time that is about mechanical, electrical, plumbing and information management so that we can train up some people to come and work in these data centers. We are at a critical skills gap shortage. And I think, you know, Anil, I don't believe that we should just be going to the middle schoolers at this point, that we're like, hey, let's get middle schoolers more into STEM and that'll solve our problems. I think, you know, we have a construction management program that has 95% women in it right now, and they are not from middle school. And we are highly, we're looking also at, you know, different communities. I know that Chris Crosby, my CEO, has supported us going to the rugby community, the women's rugby community, to go and get women that are probably more predisposed to be in our space by being from the athletic community to come and get, after they play in the Olympics, to come and get jobs in our space or in the World Cup. I think we are in a critical situation right now. So whatever you can do, whatever part of that you can play, whether it's whatever you can do at your company to help train up and create, you know, opportunities, it behooves us to do that, because that is part of the S in ESG that often gets forgotten, that we have to be a sustainable, you know, industry and organization for society, that perspective.
Pete, if you can, and then Gemma.
Sure. From a skills and knowledge, I mean, I'm very power centric, as you guys have probably already heard many times, and having worked in the nuclear industry and having been in the just fossil generation side as well, with a lot of the bridge periods and everything we talked about, and just the difference with microgrids and turbines becoming fashionable again and everything coming on site. I mean, that's a big skill set, right? You don't just walk in and become a turbine millwright, and all those type of skill sets are one, tough to come by and always in high demand, especially now. And I've always looked towards former military veteran community, because when you think about critical infrastructure, and if you lose a large node of a turbine, I mean, that criticality and standing a watch, so to speak. And a lot of our service members have stood a watch, stood a post, and they understand when you're on duty, you're on duty, and there's no time to slack. So I mean, I like the veteran community. I'd also extend it from personal experience to a little bit further to the maritime industry. We have a lot of maritime service individuals that go out to sea. There's watch standards on the merchant fleet, on oil tankers, as well as just fossil plant operators as well too. As there's more automation and just the base load fossil, or we have more renewables on the grid of wind and solar. That, don't get me wrong, they need technicians to work on wind and solar to a certain extent, but not the intensity of a coal plant, right? So as certain coal plants come off grid, that displaced workforce can definitely be turned over and reallocated to potential on-site generation or things that need to be worked in and around a data center.
Hey, Pete, I like to remind folks that we also go to the veteran community, but our current veteran community and active service is only about 17% women right now. So we can't forget about the military families that are out there as well. There are plenty of military families that have wives and husbands that are highly trained, that have moved around, and we really need to not forget to tap that part of the community in our military forces so that we can also diversify our workforce at the same time. But I think you're absolutely right about Navy nukes and maritime. It's been very helpful for us as well, and important that we take care of those folks.
I think about skills in kind of the design sector, the moving between sectors. It's thinking about sustainability and low carbon has kind of become everyday business for us across all kinds of different sectors of building. So it's kind of day-to-day business thinking about energy consumption. But when it comes to embodied carbon, I know in my sector, which is MEP, is a bit behind others. So like structures and architecture, I've been thinking about it for a long time now. It's I don't want to say it's easier, but it's concrete and steel. It's more material based. Whereas MEP, we're a little bit behind. It's not something we're used to doing day to day. Thinking about embodied carbon of MEP services, it's quite complex, and the data isn't all quite there yet, and it's not quite easy. So we do a lot of work in Arup to kind of educate the MEP engineers on how we go about doing an embodied carbon assessment and how they can think about in their kind of their usual typical designs of how they could reduce it. So there's kind of some education and knowledge sharing around that.
Fantastic. So as RICS, we also offer an introductory 3-part web class on whole life carbon assessments and a very deep dive, technically oriented, I believe 80 CPD hours, several months long certification program on whole life carbon assessment. So I think you're right, every aspect of the sector probably needs to look at skills and competencies to provide the right kind of expertise. So moving on to our next question, and I'm already seeing a couple of questions pop in that connect to our next question, which really deals about materials and equipment. And I think, Amy, you've already touched upon this idea of partnerships. I know when you talked about the work that we did a couple of years ago, I just love that house of IC, the house that IC built, in which you have so many enablers. You talk about lean principles, data, digital, and so on. I think it's very relevant to this discussion in which we're going to talk about materials and equipments used in data centers over their life cycle. How can we better integrate decarbonization of data centers with maybe even circular economy principles and other greater resource efficiency principles? So each one of you, if you can address that. And the question from Jayati that actually connects very well to this is how far supplier manufacturer sustainability discussions have gone in terms of developing actually sustainable components. So Amy, I think if you can start, and then Gemma, and then Pete.
Yeah, I mean, I think I love what you're talking about, Gemma. You're right. It's easier when you're talking about concrete and steel. When you're talking about MEP, you have to change over to systems thinking, right? It's not just about those materials. It's not just embodied carbon, but then operational carbon, which is even a greater risk, for the planet. 12 versus 28% of our embodied carbon, or of our carbon emissions. So I think when you're thinking about assemblies and prefabrication and being able to really decouple that from a very large monolithic design and understand how those component parts are interoperable together to give you a better outcome when it comes to decarbonization, is hugely important. I think the interesting part, a couple of years ago, we did some research around the MEP trade contractors, and you would probably be shocked that more of them have done, it was a very high percentage that had done design for manufacturing for not just assembly, but for disassembly and reuse, that a very large percentage of that group has been tasked with that, far greater than any of the architects and engineers have ever been asked to do any of that design methodology. So I think sometimes we have to go down to the makers and the engineers that are at our fabricators, our trade partner fabricators and our equipment fabricators to help us, because they really can eliminate waste by eliminating materials, eliminating packaging. I know we just did some great stuff with Schneider, and we are doing a standard product obviously with Schneider, but the reduction in packaging from the standard product perspective versus their iterative products that are out there is unbelievable. The reduction in copper is like world changing. And I think, again, it's partnering with those that are closest to the maker side, collaborating amongst them, and having empathy for them as well in their process will really get us much better results. And it's proven. There's empirical data around that. But you're right, Gemma. I think you have to really create an ecosystem that supports that, because you can't just assume an architect or engineer is going to design something without the makers and the owners being present to really help drive this from an innovative perspective.
Yeah, and I think I was probably going to touch on most of the things you just said there, Amy. It's about, and it's what we talked about earlier. It's about, do we need it in the first place? Like, if we, and the answer is probably yes, because we need a lot of redundancy built in. We need a lot of repeated equipment to make the data center work how we need it to work. But does it need to be new? Can it be reused from elsewhere? Can we make sure that the contractor installs it so that it can be removed in the future without damaging the materials around it? Can it be taken off site and refurbished or reused in another building somewhere that doesn't mind an older chiller, for example? And so I think there's a lot of things that we can do, and we, like I said before, we try and work with manufacturers to get data and information from them so that the data center operators, providers can choose between manufacturers, and they can choose the one that is providing data, or they can choose the one that is showing a better product from an embodied carbon point of view. So there's lots of things we can do, and kind of in the design process, there's loads of things we can do. We can check our distribution of pipework and cables with embodied carbon in mind. We can think, well, could we go that way and make the route shorter? Could we reshape the building so that the plant rooms are closer together, there's less distribution runs and all that kind of stuff? There's lots of little things that we can do. Mm-hmm. And a lot of things like that are already thought about in the kind of the cost process, because more materials cost more, so it is thought about already. But like when we understand the numbers, we can think about, well, could we choose a different material for that, or could we do things slightly differently to reduce our material usage? So there are lots of things that we can do.
The good news about having a closely coupled partnership is we eliminate that phrase, we need to engage with them early, because we're already engaged with them, right? So that's sort of the trick that we've been saying for years, Anil, like, we've got to move further left. Everyone's got to get involved. It's like, no, we're already engaged with them at all times with, product improvements and going to 1.2, 1.3, 1.4. But the nice thing is, if you are working with closely coupled partners, those innovations that we're working on with Schneider or Vertiv or Cummins or Siemens or anyone out there, our precaster, they're selling those to other people, not just in the data center world, but to the hospital world, to the manufacturing world, to the semiconductor world. It's a good thing, right? Like, it's a good thing when we can reduce carbon with one partner, because they're going to sell those products to other people. That also benefits, building data centers differently. Hopefully other buildings get built differently, and ultimately housing gets built differently. Who knows? That's what we're hoping for.
You're absolutely right. I think moving from transactional to more collaborative and enterprise arrangements probably has that benefit. And as you just explained, it benefits other subsectors also. Sorry, Gemma, and then Pete.
Oh, it's okay. I was just going to say as well, I don't think we've really touched on the lifetime of the equipment as well. So the MEP components have a big impact on the whole life carbon of the building, because they're not just installed on day one, they're installed at day, year 20, year 40. They're replaced 2 or 3 times within the building lifetime. So that there's something that's continuously replaced, and each time you replace it, you're introducing more embodied carbon. So thinking about the longevity of that equipment is really important, and how we can look after it and maintain it so that it lasts for longer.
And that's a good segue. I would add, when you're thinking about temporary power, as well as your backup and the life cycle of the data center, is that if you're designing deploying more of a modular, containerized, or fully relocatable bridge solution, there's an opportunity that maybe after the bridge period it's taking the place of your backup gens, and it's the one generator, right? So when you think about embodied carbon or reusing it or bringing it off site somewhere, that mobilization, demobilization, and accounting for what it takes to do the demob, and it's just you're using something that's modular, that again, that's dual purpose. From it can do the bridge period, but then it can also shift into backup if you even need backup on site. But it's also providing that dual purpose of your backup generators or your backup generation on site as well.
Thank you, everyone. Let's move on to our next question. We briefly touched on this earlier, but how can we benchmark success in decarbonizing data centers globally? I know iMason's Climate Accord is doing a lot of work. RICS is doing a lot of work. Gemma and then Amy, if you can touch upon how do we share best practices? How do we support that with data? So benchmarking.
Yeah, so I think encouraging to share in the first place is probably the key thing, isn't it? And making sure that people are reporting on their scope 1, 2, and 3 emissions. But I think we touched on it earlier. I think they're quite difficult buildings to benchmark against each other. They're on a global scale. They're not just one building. Quite often it's a campus development. So on day one, you're developing your site, and you might put a substation in one building, but then that building might not be fitted out, or might have a building 2, 3, and 4 in the future. So it's really hard to kind of compare building 1 to building 4, because building 4 might not have had all that embodied carbon of the site emissions put in on day 1 for it. So I think it's quite difficult, and there's different types as well, isn't there? So there's like co-location, where you've got the tenant landlord relationship, and you've got hyperscalers who are responsible for the whole building, and it's quite difficult to benchmark and compare. But I think until people start sharing that data and sharing that information, it's hard to understand what those are. And there's not really a global scheme, but I know some countries are trying to start benchmarking it. So I know in the UK we've got the net zero carbon building standard, which is going through pilot testing at the minute, and that does have some benchmarks in there for data centers. And the idea being that you have to meet those benchmarks. That it's not just embodied carbon, there's other things as well. But if you want to be calling yourself net zero, you need to meet those benchmarks. And the numbers are in there, and they're great. They're in there, that you can use them, but there's still development needed in terms of making sure that they are representative, and sharing of data and information is key to kind of making sure that those are accurate.
I think that makes a lot of sense. Several years ago, I did a project with the World Bank in which we were comparing various sectors. Walked into a room full of economists. The first thing they said was, construction is a comparison-resistant sector. I said, yeah, I guess you're right. But that doesn't mean we stop benchmarking and try and get data to benchmark. Amy?
I mean, funny enough, this is a place where I feel super positive, maybe more so than other areas. EcoVadis just changed the way that they're doing their benchmarking. We used to be benchmarked only against data centers, and now we're benchmarked against every type of building in EcoVadis, as an example. And I love the work that iMason's Climate is doing with Miranda, as well as, look, I'm sitting on the core group with GRESB and iMasons for the new assessment for data centers, for the GRESB assessments, and I have found nothing but openness, transparency between different types of data center. To your point, Gemma, different types of data center owner, operators, and developers. But the sharing has been incredible, and I think the people are recognizing that we're all on this planet together, and this is not necessarily about business at this point in a lot of ways, and a lot of like-minded people are working on a lot of these things to create at least a measurement that makes sense, that you can take action from, as however that action makes sense for you. So I'm actually quite positive right now, at least from coming back from, and maybe because I took a 4-year break and I came back to this space, that I'm seeing a lot more transparency and sharing and collaboration amongst even competitors in this space that I think has changed in the last 5 years.
We are noticing that also, being working for RICS, great privilege to talk to experts like yourselves globally. I think we try to push a standard for benchmarking cost. That was a pretty steep climb to convince people to share data, but you have to make carbon transparent in order to convince. It needs to be visible that you're achieving the target. So then there's an inflection point where folks are more keen to share that kind of data. Pete, anything you want to add from the power side of things?
I had something. I was going to be a shameless plug for iMason's Climate Accord, but Amy already hit that.
Hi.
So I would just say more participation and visibility and benchmarking with standardization from iMason's Climate Accord, and any support we can continue to put that direction, I think would be mutually beneficial.
Pete, let me make things easier for you. My next question is, what role can professional organizations play in driving decarbonization of data centers? Plug away as much as you want.
I'm actually in one of the working groups. So iMason's Climate Accord has 3 working groups, and I'm on the power committee on the working group. And the more participation and openness, we meet every 2 weeks, and we're really trying to put standardization and benchmarking in place for and options specific to the power side. I know in equipment and the other working group, they're doing the same. But I started in January in that group, and Mike Donahoe and Tom Quinn and others and hyperscale engagement. It's really an amazing. I look forward to it every 2 weeks. I get all my homework done whenever there's assignment. I would just suggest that more participation. And if you're not a member of iMason's and iMason's Climate Accord, I suggest that your organization get involved, because it's a great collaborative effort. It's not just microgrids. There's turbine guys, there's the emissions guys and girls, and it's just a wonderful collaboration that, and again, I look forward to it every 2 weeks in that working group to participate and just listen to the thought leadership and actionable things that we can do coming out from it.
I might add to that, by the way. I did a shameless plug, as well. But I would say, if I were giving advice to the associations and organizations, the one thing I would say is business models are changing rapidly. And we were so impressed with GBI that when we came to them with the idea of doing the campus approach, that they were open, they listened, we collaborated, and then they rolled something out within months. I mean, that is fantastic when you think about how industry has to work with these associations. I just think that was an amazing fact to me, and just experience that business models change, associations have to change, interactions, and yes, everybody should get involved and share.
Gemma, what to you?
So I know Arup are involved with helping out in the iMasons, and it's such a great way to kind of bring all these great minds together, isn't it, and have these discussions. So I think anything that they can do is a positive change.
Fantastic. Thank you. We're pretty much running out of time. So last question, use that as rapid fire closing statement as well. What should we look forward to over the next 5 to 10 years in this space? I think that's probably too long. Things probably change much faster in this space. But what are some of the things that you are looking for in the next 5 years? Pete, Amy, Gemma.
I'll go first. I think the role of utilities is going to become more and more important. It's already is important, but I think if we can accelerate interconnection through the flexible pathways, temporary feeders, mobile solutions, everything I kind of mentioned, we get there cleaner and faster, and also bring a lot more resiliency to the grid itself, and having data centers be viewed from a perception point of view as a grid asset versus a grid liability. I would leave it at that.
Amy?
Yeah, I thought the time frame was going to be like, what are you going to do in the next 6 to 8 months to 12 months? Not like to your point. I think we need more innovators out there. We need to teach our teams how to challenge and how to have 1% incremental improvements at all times. We can't always hit home runs like everybody moves to nuclear tomorrow. That's not gonna, these things happen a little bit slower, but there's a million small 1% improvements we could make as an organization and as an industry. Focus on what you can do right now to make things better.
I think I'd like to see more circular thinking in the design process, making sure that everyone's thinking of the whole life cycle of the building and not just for day one, and then more availability of data, particularly around MEP equipment.
Fantastic. Thank you so much. I really appreciate the three of you taking the time, also doing the prep sessions, tech checkup, and all that. I know you're very busy traveling. I think this was a valuable session. I learned a lot. We will continue to work in this space, and anything RICS can do will definitely work with iMason's Climate Accord. So with this, I'm going to thank our panel, iMason's Climate Accord, Miranda and Santiago. I hope you're watching from France as well. This session was truly a very good session. So this a reminder that we will publish a recording and written summary of this webinar online. Please feel free to share these with your professional networks. Please also take a moment to let us know what you thought of today's session by completing the online poll, which will appear on your screens at the end of this webinar. Also, tune in to our next webinar, which is on 11 June on deconstruction, the cornerstone of circularity. If you need further information about RICS and WBEF, please do see us on our website or on LinkedIn. With that, thank you very much. Until our next time, goodbye.